This is Shafat Khan on your screen. I hope you're doing well. So today we are going to do winter 2024 paper. Okay, let's start. This is Cambridge CIE past paper 2024. Okay, paper 4.2. Let's start. This is the data sheet that is given to you on your exam. And let's begin. Okay, so question number 1 says a metal wheel consists of an axle A, 8 spokes and a rim as shown over here. These are the spokes. This is a rim. This is an axle. Point X is on the rim at the end of one of the spokes. This is the point X that they are talking about. The rim has a radius of 0.85 meters. So the radius, meaning the length of one spoke, length of each spoke is 0.85 meters. The wheel is rotating clockwise with an angular speed of 140 radians per second. This is the angular speed. Angular speed is represented by the symbol omega. So it's given to you, it's 140 meters per second. And the radius is given to it 0.85 meters. For point X, determine the speed. At this particular point, you need to determine at what speed is this object moving. Now, because this is circular motion, the speed must be the tangential velocity, tangential speed. So to find this tangential speed, there is a formula that we have studied in circular motion. V is equals to R omega. Okay, where V is the tangential speed, R is the radius of the circle, and omega is the angular velocity. Simply just multiply them, get an answer. 120 meters per second. That's it. Next part says find the centripetal acceleration. Now, so to find the centripetal acceleration, we need to use the formula of centripetal acceleration. There are two formulas for calculation of centripetal acceleration in circular motion. First formula is V squared over R, and the second one is R omega squared. You can use any one of them because now you have V as well as omega. So I've used V squared over R, the answer that I got in the previous one, and then there you go, 1.7 raised to the power of 4. Now there is a uniform magnetic flux field of flux density 0.18 Tesla into the plane of the page. State Lenz's law of electromagnetic induction. This is for 2 marks. I would recommend you guys to copy this law down as it is because this is very important. Okay, they're asking us about the Lenz's law. Lenz's law is a modified form of the law of conservation of energy that tells us about the direction of the induced EMF. The direction of the induced EMF will always be such that it would produce effects which will oppose the change that caused this induction. Okay, so meaning the direction will be such that it will always produce such effects that those effects will always oppose the cause that is responsible for the induction of EMF. Okay. Part 2. Show that the time taken for X to complete one revolution is 45 milliseconds. Now, this is X right here. We know that the omega is 140 meters per second. They're asking us for the time period. So you should know by a fact the formula for calculation of omega, the definition of omega. It's 2 pi f, right? 2 pi f, which is equivalent to saying 2 pi divided by the time period. So if you have omega, you can use this formula. Omega is equal to 2 pi divided by time period and get an answer. The time period is already, can be calculated using, actually time period needs to be calculated. Omega is given to you. Right here, 140. So omega is 140 radians per second. Omega is 2 pi over t. 2 pi over omega, 2 pi over 140, you'll get for 0.045 seconds, which is the same as 45 milliseconds. Then it says calculate the magnetic flux cut by spoke AX during one revolution of the wheel and give a unit for your answer. They're asking us for one revolution only. They're not asking us for multiple revolutions. So, well, generally the formula for calculation of flux, which students usually remember, is NBA sine of theta. Because they are perpendicular, it's a perpendicular field. So theta is 90 and sine of 90 is 1. So this whole factor can be ignored. We're only left with NBA. Now the N is, in this case, because they're asking us for only one revolution, this is going to be just 1. We are only left with B and A. So just multiply B and A and you'll get your answer. B is given to you as 0.18 and A can be calculated as pi r squared because it's a circle, right? Area of a circle is pi r squared. Radius is given to you in the beginning, 0.85. So do the pi r squared thing, get the area, plug both of these answers into your equation and you'll have your final answer of magnetic flux. The unit of magnetic flux is Webers. And this is going to earn you 3 marks. Then next is determine the magnitude of the electromotive force induced across the spoke AX. So we need to calculate the EMF basically using Faraday's law of electromagnetic induction. EMF is equals to rate of change of magnetic flux linkage. So it's basically the total change in flux divided by the total time. So we know the magnetic flux for one spoke AX only is 0.41, right? When it is rotating, so it's cutting across 0.41. So 0.41 divided by the time it took. How long did it take to complete one revolution? It was 45 milliseconds, right? So the magnetic flux cut during one revolution is 0.41. And the time it took for one revolution was 45. And Faraday's law of electromagnetic induction tells you that the EMF induced will always be the amount of magnetic flux cut divided by the time it took for cutting it, right? So amount of magnetic flux which was cut during one revolution is right here, 0.41, okay, B times A. One revolution means one complete area, right? So B times A, and the time it took was 45 milliseconds. So just divide these two numbers, you'll get your answer. 0.41 divided by 0.045. It's 9.1 volts, okay? And use Lenz's law to explain whether the potential is higher at end A or end X of the spoke. So for Lenz's law, according to Lenz's law, the EMF induced must be rate of change of magnetic flux linkage, right? Now, the rim is moving in clockwise direction, as shown over here. They told us that the rim is moving in clockwise direction. That means there must be a force applied on the rim downwards in the blue direction, right? This is the normal force that is keeping the rim, that is rotating the rim. Now, if current has to flow through the spoke, through AX, it has to flow in a particular direction. The direction should be such that it should produce a force that opposes this existing force. Okay, blue arrow represents the existing force, the force that is being applied already, and the red arrow represents the force that should exist due to Lenz's law, due to the induced EMF, because this red force should always oppose the blue force. Now, this red force will be acting upwards. The field lines are into the page as given in the question already. Into the plane of the page, given over here. If we use Faraday's left-hand rule, Fleming's left-hand rule, we can get the direction of induced EMF here. So using Fleming's left-hand rule, just put your first finger in the direction of the field into the play page and put your thumb upwards. So the direction of current is going to be from left to right. Okay, so if the direction of current is going to be from left to right, that means there is a higher potential at A compared to X. Okay, so A must have a higher potential. Let's write down the answer. The force must be in the anti-clockwise direction, therefore the current flows from A to X. Okay, so there is a higher potential at which A? And at an A. Okay, guys, with this, question 1 has been completed. So we'll discuss question 2 in the next lecture. Thank you so much.